Alrighty, folks, welcome back to another video from Yates Computers Tips and Reviews. Well, it's 2023. It's rabbit hole year. So, I know I've covered a lot of this already in individual videos. Started out with the Hyper-V, went to internal, external security. Wanted to touch base again on one other factor. Is your network layout, because I've got a lot of different videos out already on that network cable, all those type of things. Go back and watch those because they're very important to how everything ties in. And you might wonder, well, why does he have 7 videos on network cable? Why does he have a video on switch? Why does he have a video on hub? Why does he have a video on NIC card? And why does he have... Because these all have to be broken down and explained in a way that when you get to this kind of a subject, when you get into the rabbit hole, you need to find out what is the difference between this and this. Why would I need this over this? Maybe you need 2 ports, not 4 port. You don't need to have a 4-port single card. You can have 2-port, 2 cards to have the same factor. If, again, go back and watch the videos. If your case supports it, if your motherboard supports it, your power supply supports it. This is the rabbit hole. I just brought up 3 variables on adding a NIC card. It's crazy. This is what can make computers and technical stuff so hard. It's the little tiny pieces. Oh, I just want to add this card. Okay, what slot is it? What port is it? As you can tell, they're different cards. Huge card, little card. The new cards are tiny, tiny little cards. I know I have a new one around, but it's like, this is a little tiny card. Card's barely big enough for the port on the end. That's crazy. Technology has gotten to a point where everything's gotten so small. But, is it small? Yeah, things have gotten pretty small. I've got a video on the little computer I got here. The unboxing and all that. Little tiny thing. That's the whole system. Compared to the NIC. Old NICs. That thing has 2 NICs, Wi-Fi card in it. 2 video displays out. I mean, it's crazy. So, to go from something like this to a whole unit that has, 2, 3 different Wi-Fi, has the Wi-Fi in there, so it has 3 different devices that can communicate out. That makes a world of a difference. So, wanted to go through this again about simple network configurations. Could get really complicated. Talked about last video, VPN. Everybody's pushing VPN. Knowing your physical hardware. Buy some business grade ones, even maybe some home ones, will support a VPN connection in this physical device. So anything that connects to this device will go out on the VPN. That is a different network architecture you need to think of when you design a network architecture, is what these physical devices actually do. You can get a business grade that has a VPN, firewall, wireless, wired, all in one unit. Again, how many ports it has and all of that are completely different. You can run out of here into a network switch. A big 50 port, 74 port, one of those big massive, like 300 port switches, that go in a rack. That's multiple U's. There's all kinds of weird switches and configurations out there. maybe you come out of here into your router that handles all your traffic into your switch stack. Kind of funny, you have a whole switch stack with a router that runs into a router. Well, because this is acting as your firewall, so you don't need a firewall. Well, then you have your VPN actually attached to this that goes out. So it's kind of an interesting concept to know. And you might not want to put a VPN in between your firewall, because of security reasons I brought up in the last video. So depending on how your network architecture is done, how it's laid out, what pieces of hardware, all of those type of things, I wanted to go back through this because this covers the security side of the hardware architecture, where you might not realize that. Going back to VPN on computers and admin rights. You don't want to give user admin rights because they might turn on VPN and bypass whatever security features you have on your hardware. So that defeats your architecture of your network because now they're going right on by it. So I wanted to do a short little video on the hardware architecture. You can go back, watch all the Wi-Fi video, router videos, switch videos, NIC videos, network cable videos. All of that's relevant to this. Knowing Cat 6, Cat 7, shielded, unshielded, Cat 5e, Cat 5e shielded. All of this stuff comes into play. Knowing Wi-Fi, G, 6, N, B, A, all those things come into play. Knowing your internet speed, your bandwidth, all of those things come into play. Because one of the interesting things is you might have a whole switch stack that are gig switches, could be 10 gig switches. Go out to this device that goes out to your internet. People might think, well, that's kind of weird. Why would you do that? That device does not support a high-end switch stack and doesn't support that. Goes back to what I mentioned before. What's your internet speed? If you got a 200 meg internet speed, a 300 meg internet speed, and you have a gig NIC that can talk to your modem, whatever it is going out at 300 meg, guess what? This will support your internet speed. You might have a 10 gig rack of switches because it's talking to your servers. It's talking to your data centers. It's talking to all your storage devices. All of that on the network. That 10 gig switch is not going out to the internet at 10 gig. That is your architecture of your network. Of course, you don't want to put this in the middle of that stack, slowing down your stack. Understanding I can hook this device up and I don't need a whole stack that's chained together. Maybe I need 2 switches. Maybe I need one that has PoE to control phones or control something else. The other one I don't need PoE. I have 4 ports out. I can connect directly to those switches and let it distribute. You don't need to have a stacked switch array. Keeps your costs down. You don't have to have the same really expensive PoE switches all the way down. You don't have to have a lot of that stuff. You don't have to buy. There's switches out there that standalone switches that are 10 gig that you can get for a fairly good price. Knowing your architecture of your network will help you out knowing your hardware. Knowing the speeds of what you're going to need. Knowing your speeds. A lot of people would think this is crazy. This is absurd for a system. What if you do load balancing on those 4 ports? That's an option a lot of people probably don't think about. Well, when you're in a big business, you might consider that. A lot of home users and other people probably have no clue what that term even means. What that means is these 4 ports work together as one, sending traffic, receiving traffic. They can use 2 for in traffic, 2 for out traffic. No waiting, no cross-talking, no nothing from traffic going in and out. They can use 3 of them going in and 1 going out. Or 3 going out, 1 going in. Depending on what that server is actually doing. Maybe it's sending out video files and sending out a lot of data. That import is taking the request. I'm going to need file from December of 2021. I need that video file. And it starts sending that. Send it through those 3 ports instead of 1. Load balancing. This is where knowing your layout, knowing, okay, now I'm going to need 4 network cables to that same server. Maybe you have multiple of these cards in there. You might have 4 ports all in. You could have 8 ports out to get that bandwidth speed up if you need it. And that can be all internal. That does not have to be external. You can have that slow internet speed because your people are in there editing videos, doing other things on that server. Knowing that bandwidth limitations, knowing how the architecture of your network set up. So I wanted to go through that because that is really where the rabbit hole actually starts on laying out a network. Going into those configurations. Knowing this little simple factors of what hardware and what you're going to need and your layout of your network. I did mention one of the small little factors there. It might take 4 cables. How many is your workstation going to have? I know some workstations, they were all going to fiber optic to carry the bigger bandwidth. Now you got switches out there that can handle a lot of traffic. You have NIC cards that can handle a lot of traffic. I did mention single dual port NICs. Some of them have 3 or 4 ports that are small. Not like that big giant old server card I have. Maybe you need a 2-port NIC for load balancing on your actual workstation. This isn't your server now. This is your actual workstation. Maybe you need a couple of these added with dual ports. 1 for incoming, 1 for outgoing load balance. I'll let you think on that one. How many network cables do you need to that workstation at that point? How many keystone jacks in the wall? How many ports do you need? How many network cables from that workstation up the wall into your data center need to be run? Are you going to put a little switch there so you can run out on 1 line? Because you only have 1 line in the wall when you actually need 4 or 2. This is all the architecture of your network, knowing what you're going to need. This has become a bigger and bigger thing with the faster and faster speeds and all the data. And I'm not going to say all the data as in you're doing more jobs. I'm saying because now you're talking HD, 4K, 8K, high definition videos, and other things that take up more data and more bandwidth when you alter them or edit them. It's a lot more traffic for it. Meaning you might have to look at some of these options. So this is where the architecture of the network comes involved when it becomes the rabbit hole situation. Because a lot of people are like, oh, just run fiber. Okay, well, fiber is a whole different deal. Now you're opening up your walls, running fiber from your comm room, communication room, wherever it is, all the way out. Maybe you need to run lines to a central location. If you have a bunch of workstations in an office, maybe you need to have a certain switch in there that handles all that traffic in that office. And then from that switch, it talks out to your switch stack. This is all the architecture of the network. Maybe you're on different floors of a building. Maybe you're in completely different buildings. Maybe you're in different towns, different states, countries. This is your architecture of your network, how it communicates. Then you need the faster internet. Then you need to have private channels open between where these places are. So this is where the architecture of the network can get complicated. As simple as you have a entire 5th floor business, time to expand your business, and the only place that they have for you to expand on is the 8th floor. And you take a bunch of the 8th floor for your business. Move all your CEOs and other people up there and actually move the business architecture of the business on one level. Those CEOs and stuff have to get data from there. How are you going to do it? Maybe you bring in a whole research and development category that you never had and you put them on the 8th floor. Not knowing, is that going to be a future thing for you? So why move everybody up if you're not too sure you're going to have that department or anything for the next 5 or 10 years? Knowing all of these little things changes how you design your network. Having the future growth of your network, knowing how to do all of this. Of course, that's all big business. Well, guess what? This is going to come to the home. People are gaming and doing a lot of stuff where they want fast speeds. They want this, they want that. Well, if you're gaming on just a single NIC, what kind of firewall, all of that type of stuff, how is it lined up? Who else is using your internet as you're gaming? If you got 4 other people in there gaming and you're going through the same device, you're going to be tying up that device a lot. That's going to slow down bandwidth. Knowing all of the layout and architectural design of your network can help you. People are streaming. People are doing other things nowadays. Knowing all of that. Knowing, are you gaming wired, wireless, what bandwidth, Wi-Fi 6, G, N, all these things come into play. Security keys, encryption, all these things come into play. So I wanted to go through and actually just explain how complicated a network can actually get. And so people understand that this is why I have all those individual videos. I know I've gone through and summarized how it all works together, but this is the rabbit hole side of it. When you get down to it and you decide, well, I would really am interested in, increasing my speeds, increasing your speeds to where and how? A lot of it is, I want to increase my speed so I get faster internet. Yeah, faster internet to the internet will help you on that. But if you have servers and you have other things running on your network, web hosting, anything else like that running on your network, on a virtual machine, a physical machine, any of those type of things, put a virtual machine on there that's going to start scanning your network, scanning your systems, that's bandwidth through your system. How you have that architectural layout set up, if you physically use just this device. That's all. And you have a cable modem or whatever other device to go out to the internet that this is attached to. This is handling every piece of traffic sent through your internet and through your internal and through your external. You may want to actually add a physical switch after this device that can handle some of that traffic. That would know, okay, this traffic is coming from here off to this. Where anybody that's going through the internet is going through and going into here, getting routed, getting secured, firewall, all of that type of stuff, VPN, out. Where you can lift some of that traffic off of here. All your wireless traffic comes in here, not into your wired network. It can come into here and then go that way into your wired network. But that is part of the architectural layout of the network, understanding that part of it. So you can actually slow down your network due to your hardware. So that's why in the other video I mentioned about business grade units. Knowing how much bandwidth and how much traffic these can actually handle. You might be interested in going up a grade. There's actually, I believe, 2 grades of these I mentioned. There's a lower end, and then there's like a professional end, and then you get into like the business grade. You'll see the differences. The prices are different. So that is the hardware layout. Knowing how all of this stuff is actually connected, knowing how that's done, how it communicates, because you get into some of these virtual machines and you have multiple things running through one line on that NIC out, and you have 4 or 5 virtual machines all communicating to the same device. You gotta remember, that's gonna be a lot of traffic to that physical device. So knowing your architectural layout is important. It can get confusing, can get hard, especially if you get into businesses with multiple networks, multiple switches, different VLANs, all that kind of configurations that come into play. VLAN configurations can be done on hardware. So, wanted to go through and explain some of that. Let people know to look at that architectural layout. Daisy chaining wirelesses. Got video on multiple routers, multiple wireless, how you can do it, how to hook it up, depending on what ports. If you want this unit to handle out all IPs, all traffic, so you can monitor anything on that network through one without having to log into both to see who's doing what, you can do that. This device can handle multiple units handing out IPs, knowing that you have a good enough device that can do it. You don't want to buy the cheapest, lowest grade unit trying to get it to double function 2 units. Knowing those type of things. Might be just easier to log into both of them and monitor them to see who's doing what, who's logged in where. That's a simple architectural network. Knowing when you want to get into higher speed, you want to load balance, you want to do other things, you get into more complicated things. There are more features out there that I have not really covered because I don't really use them on a daily basis. I don't hardly ever even use load balancing. We probably should be, but we're not. We don't. We're not to that point where we're transferring that much data. Sure, there's a lot of other businesses out there that are, I've mentioned it, video editing and all of that type of stuff, that should be using load balancing. If I set up a system here to do my video editing and all that type of stuff, where I can go onto my laptop and do it I'm going to be using basically a load balancing. But the way my network's set up is it's all bridged by Wi-Fi. So it really doesn't do me any good. Not to mention, the Wi-Fi I got is above the bandwidth that I need anyways for my internet, so it don't matter. Most of it I download directly in that computer. I do what I got to do. There's no data server that I put it in and all that type of stuff. Have my backups, have all of that, so I got my security side covered. So I hope this covers enough of this and I don't really scare anybody about the networking. If you get scared, go back and watch those videos that break down what each piece of hardware does. This subject is not going to be for the everyday home user. This is going to be for your heavy users. There's going to be very few. If you're doing a home business or doing something of that sort, then this might come into play. This might be a subject you did not even know about you could do. That you can then go, oh, I can do this now. This will make my life easier. So that's why this video is out there, is to elaborate some of these things that I feel don't get talked about. I don't see it talked about. So this is why that video is out there, is to bring this up, because if you're getting into the tech field and you're learning some of these are things that might come up later on that you're going to need to know. So again, thank you for watching another video from Yates Computers Tips and Reviews. Make sure you hit the subscribe. Make sure you let everybody know I'm out there. Because you might not need this information, but one of your friends or one of your coworkers might be actually struggled and stumped with something right now that I have a video on. Especially my end of year test video. I don't see a whole lot of people been watching that. But I'm telling you, I bet you probably have that problem at home, or someone you know has that problem right now. Because it's a big problem I've been finding. A lot of. So let me wrap this one up. Thank everybody for watching.